question relating to the prelim exam of 2022. We're looking at the rates of reactions. We look at 5.3. The question says 11 grams of magnesium ravan reacts with 0.25 mole per dm cube of hydrochloric acid solution at a temperature of 25 degrees Celsius according to the following balance reaction. So we got magnesium in this flask with hydrochloric acid in the flask, and then magnesium chloride is formed in the flask and the hydrogen gas is released. And as the hydrogen gas is released, you can note the amount of hydrogen gas released per time. That means they can record it. So as time goes on from 0 to 3 minutes, at 0 minutes we can see that there is no hydrogen gas collected, and as we go up we see 17, 25, 33, 35 centimeters cube of gas is collected. And using that collection of the gas, we can work out the rate of the reaction. Use the graph paper that is printed at the last page of the question paper. Plot a graph of these results. So we should use time and volume. So okay, when we draw a graph, we can put in a heading. We can say, okay, here's our graph. We must use a heading we should use a graph paper at the end of the book. We can say graph indicating the relationship. We can have a graph between the volume of hydrogen of hydrogen produced per time taken, per unit time. Okay, in our question we see that it didn't give much marks for the graph that is supposed to be plotted, but we'll just do it a little bit more detailed, right? So then here we must calculate, we must have minutes on the x-axis, time is on the x-axis, and volume on the y-axis. So volume of H2, you can write it down here. You can say volume. You can say volume of H2. Of H2. Oops. And that will be written in centimeters cube. Alright, and then you see the volume, and we can take the volume according to this. We'll see that the volume goes from 0 to 35 centimeters cube. So we can put it down as 0, we can go 5, 10, 15, 20, 25, 30, 35 centimeters cube. And then we can look at time at the bottom. And in what unit is our time worked out in? Minutes. Nah? So you say time in minutes to 0 to 3. Alright. You can say time is calculated in this is 0, 0,5, 1, 1,5, 2, 2,5, 3, 3,5, more or less, right? So then we must plot our graph. So plotting our graph, we see 0 is 0, time is 0.5, and you got 17. 0.5 and 17, 0.5 and 17, so that's 0.1. Yeah, 0 and 0 is correct. 0.5 and 17, more or less there. 1 at 25, 1.5 at 30. 1 at 25, that will be there, and 1.5 at 30, that will be there. At 30, that will be there, and then if you take it up, 1.5 at 30, 2 at 33, 2.5 at 30, 2 at 33. You can see here this is 2, and you can go to 33 here. It will be around there, and then this will be 35 for the next two readings, 3 and 3.5. 2.5 at 30 and 3 at 35, 2.5 at 35 and 3 at 35. Right, that's what we've got. And then we must draw a graph. Let's try and get a nice graph here. I'll try my best. And then it's a straight line at the end. Okay, we shouldn't have dotted lines. It should be a smooth line. Make sure it's a smooth line. Okay, it should be a smooth line, and we see that this is a straight line when it comes here, right? As it comes here, it's a straight line. When it reaches 3, 2.5 and 3, it's a straight line. Okay, it will be a straight line. Ish. So that will be a straight line, right? So the reaction reaches completion. All the gas has been released. Okay, that was the first part of the sum. Continuing, that was 5.3.1. Use plot the graph of these results. Use the graph and explain what happened to the reaction between 2 and 3 minutes. Between 2, it was going for 17, 25, 30. The reaction was quite rapid, and then between 2 and 3, the reaction rate decreased. 5.3.1, 5.3.2. So this was 5.3.1. Let's just write it on top. 5.3.1. Going down. 5.3.2. The rate of the reaction decreased. 5.2.3. Okay, the next question. In the second experiment, the concentration of the hydrochloric acid changed from 0.25 mole per dm cube to 1 mole per dm cube. So the concentration increased, so the rate of the reaction will increase. So the reaction will reach completion quicker. Draw a new curve on the same graph paper to show what effect it will have. Label the new curve X. So okay, we'll see here's our graph. Alright, I'll just use a different color. Maybe I'll use the green color. If this is our graph, then basically we don't know when because they didn't give us results, but maybe I'm just putting a point here, right? And the reaction will reach completion at an earlier time. and the rest of the reaction should be similar to this. And it should start at, okay, something to that effect. And they say label as X, no? So we label this X. Okay, so that will be question 5.3.3. So that's 5.3.3. Alright. Okay. So assume 5.3.4. Assume the molar gas volume at 25 degrees Celsius is 24,47 dm cube per mole. Calculate the volume of acid that was used in the first experiment when the reaction was completed. Okay, so now what we'll have to do is look at the equation. So we got a number of moles is 24,4 dm cube. So there's a volume, molar volume, right? The molar volume of the gas was 24,47 dm cube. But if you look at our case, we see how much volume we got, 35 centimeters cube. So we can calculate the number of moles. So 5.3.4, 5.2.3 will be X on the graph paper. So 5.2.4, we see that we can work out the number of moles of hydrogen. So we say number of moles of hydrogen gas produced will be actual volume over the molar volume. The actual volume that we've got was 35 centimeters cube. So we have to divide it by 1000. That will give you 0,035 over the molar volume, which was given as 24,47. 24,47. That's given in the question itself, right? Here's it, 24,47. And then if you work that out, we'll see if we calculate it, we'll see that 0,035 divided by 24,47 will give us number of moles 1,43 times 10 to the power minus 3 mole. Okay, that's what's given. Then if you look at the concentration, we can say the number of moles of HCl will give you twice the number of moles of hydrogen. Right. And then looking at that there, we can use that to calculate our number of moles of hydrogen. That will be equals to 1,43 times 2, 2,86 times 10 to the minus 3 mole. There's the number of moles of hydrogen that we have. So if you look at working out the volume, we can say concentration is equals to number of moles divided by volume. So if you take it further, the number of moles we know is 2,86 times 10 to the minus 3, and you want to work out volume, and your concentration is 0,25 mole per dm cube. It's 0,25 mole per dm cube. There we've got it. Right, and that's 0,25. 0, Right, and if you have to work out V, you can say V is equals to 2,86 times 10 to the 3 divided by 0.25, and that will give us a volume of 0,11 gm cube. Okay, so that will be the answer for 5.2.4, and that will be the end of question 5.